We're airborne.
December 7th, 1941, a date which will live in infamy.
After the attack on Pearl Harbor, the U.S. had 2 years to rebuild the Navy into the force that helped win World War II. In today's era of great power competition from China and Russia, officials say the Navy won't have that kind of time. The pace of warfare at sea in the 1940s was the pace of ships and airplanes. The pace of war in this century, if it occurs, will be the pace of photons and electrons. The first country that figures out how to fight effectively with those is probably going to win. There will be no 2-year learning curve. There will be no time to figure out during the fight.
No matter how long it may take us to overcome this premeditated invasion, the American people in their righteous might will win through to absolute victory.
When we talk about failure, I actually really couch it a different way. It's called discovery. If you do this right, you will try many different ideas to solve a problem. If you try 10 ideas, maybe 8 of them will not work, okay? That could be couched as failure. I consider it discovery. I've discovered what does not work. Thomas Edison was famous for this one. He has a quote, to paraphrase him. When he invented the light bulb, they said, "How were you such a genius?" He said, "I wasn't a genius. I just found the 5,000 ways it would not work. And eventually I stumbled on the way it did work." And that's the kind of courage that I'm talking about. It's the willingness to be able to discover, and if you don't find the solution the first time, you don't get discouraged, and you're not afraid that your boss or your peers are going to look at you and say, "That person did not succeed." Instead, you say, "No, I just discovered what doesn't work, and I'm going to find a way of solving this."
Rapid advancements in technology outpace military acquisition or doctrinal development. So Navy and Marine Corps officials are using a series of advanced naval technology experimentation exercises, or ANTX, to shorten that timeline gap and ensure operational forces in the high-tech battle space are equipped for the high-end future conflicts. The ANTX exercises focused on technologies to address operational challenges in integrating information warfare into the fight. These include communications, sensors, countermeasures, command and control, strikes, non-kinetic fires, counterintelligence, surveillance. Some 60 defense contractors, technology companies, military laboratories, and academics participated in the exercises, which wrapped up Tuesday with briefings to senior officials over 10 days at the Navy's offshore San Clemente Island ranges and San Diego labs and facilities. Participants demonstrated mature systems and technologies for possible follow-on development. Officials want new command and control and surveillance technologies that give Navy and Marine Corps forces an edge over adversaries in highly contested, high-tech environments, and deny adversaries those same capabilities. Brigadier General Christian Wortman stated, "We know we are in a fight to sustain and expand our operational advantages. Many tech solutions are information-based, and that is right in our strike zone." William Bray, Deputy Assistant Secretary for Naval Research, stated the following: "Tech must enable naval forces to pivot quickly and move to the fight. Be agile and quick to adapt to adversaries or threat that may be out there." Bray also stated that tech also must be effective, affordable, and developed with labs and engineers as well as warfighters. Industry and academia working together to find tech solutions to specific problems. Bray also said it's very, very important that we have one integrated team moving forward. He said, and each ANTX gives us a great opportunity to really assess the technology from all those aspects and then enable decisions going forward. ANTX gives defense contractors and other commercial or private tech firms, small or large, a venue to access naval ranges, facilities, and simulation centers through various agreements and authorities. Their tech systems and concepts go through realistic scenarios, some done through simulation models, others out in the field, and with sailors and Marines providing input, feedback, and assessment. To speed the process, the Navy uses a method called Tactics and Technology Exploration and Experimentation. The TNT-E2 method provides a research and development ecosystem where engineers, scientists, and warfighters collaborate and help identify new technologies that can be rapidly prototyped and quickly fielded to sailors and Marines within 12 to 18 months. We bring those warfighters together face to face with technologists, and that's where the innovation happens. That's where the exploration can happen. Jackson said at ANTX, collaborations and partnerships formed on the beaches, in the dirt, in the lab environments. The process and data-driven approach culminates during ANTX. Senior officials decide which tech would be examined further at fleet or field exercises or rapidly prototyped for field or acquisition. Engineers stand alongside warfighters and discuss their designs. They get to say what works and what doesn't work in the process. Rich Byers, systems engineer with Naval Surface Warfare Center, Panama City, Florida, and a naval integration lead during the ANTX West, told USNI News, tech that isn't ready for prime time might benefit from rapid prototyping or science and technology investment, so it helps guide our forces for the tools they may need in the future. Some 70 assessors, 35 Navy or Marine Corps operations, and 35 scientists or engineers use tools developed by NSWC Panama City to collect thousands of users' assessments from engineers and boots-on-the-ground Marines and sailors. Those assessments are what is critically important at this event. Jackson said, once you start unleashing that ingenuity, it's pretty awesome. There is coding and integration going on. Since its 2016 start, the ANTX series has seen some successes. The 2017 Ship-to-Shore Maneuver Exploration and Experimentation held at Camp Pendleton had 75 of 132 participating technologies demonstrate on the beach. More than 50 were prototyped, and 4 led to programs of record. Jackson said, including unmanned swarming technologies and mission planning tools. Jackson also stated, there were initial skeptics. People were shocked at the scale that we assumed. They thought we would fail. Basically, she said, but we were able to show a progressive approach that got more and more fidelity and more rigorous as you move throughout it. We were able to show that we could be fast, we could respond within 6 months with hundreds of different technologies in the hands of warfighters, and we had a way to characterize them sufficiently to make decisions about the next phase.
Premier Information Warfare Naval Conference and Exposition on the West Coast kicked off at the San Diego Convention Center February 21st. The 3-day conference, now in its 27th year, brings military and industry leaders together in a single locale to encourage discussion with the makers of platforms and the designers of technologies impacting the warfighter and information domain.
It's very clear to me that information, data, all of that plays a tremendous role in making teams more competitive. The evidence is really overwhelming that the teams that can better manage their data, better manage their information, and use all that to good effect, those are the teams that win.
In the future, soldiers needing replacement parts may turn to 3D printers to rapidly deliver reliable and ultra-strong metal parts. At the U.S. Army Combat Capabilities Development Command's Army Research Laboratory at Aberdeen Proving Ground, Maryland, materials manufacturing scientists say this technology may change everything.
I think it's going to probably revolutionize logistics, so we're still a long ways out from that, but really additive manufacturing is going to have a huge impact on sustainment, so you can really reduce your logistics footprint. So instead of worrying about carrying a whole truckload, convoys loads of spares, as long as you have the materials, the raw materials, and a printer, you can potentially make anything you need.
Army researchers are looking at new technologies to create steel alloy parts from powder using a laser.
For example, we've done some stuff with our collaborators where we're able to print parts with internal structures that they would not necessarily be able to create with that much dimensional accuracy, where they use to try to mill or like machine a part.
The researchers are using an alloy originally developed by the U.S. Air Force. The Army adapted the metal to powder form.
This material that we've just printed, developed processing parameters for, is probably about 50% stronger than anything commercially available.
For Army applications, the key to usage is certification. Will the part work as needed in a battlefield scenario?
For instance, we've printed some impeller fans for the M1 Abrams turbine engine, and we can deliver that part. They can use it, it works. That may be good enough. You'll be able to get your tank running again for hours or days if that's important to the mission. But on the other hand, we still need to be able to answer, okay, does this perform as good as the OEM part? Does it perform better, which is ultimately what we would like to help mitigate the failures that we see in the first place.
The Air Force initially developed this alloy for bunker-busting bomb applications. They needed a metal that was very high strength, but it also needed to be economical.
The nice thing about that for the Army is it has wide-ranging applications. So we have interest from the ground combat vehicle community, so it could be used for replacement parts. A lot of our parts in ground vehicles now are steel, so this could be dropped in as a replacement, not having to worry about material properties, because it's going to be better. So the chance of it breaking are going to be lower than your previous part.
The laboratory is working closely with industry and academic researchers to model new alloy designs, perform computational thermodynamics, and expedite the process to get these materials to soldiers.
What does the next generation alloy look like? How do we take the knowledge we learned from this steel and push it even further to get even better materials?